So here we need to prove the following identity. Okay, let us begin. Now here, to prove this problem, we're going to make some assumption here. So we'll suppose that alpha minus beta, that does b equals to a. Then beta minus gamma, that does b equals to b. And gamma minus alpha, let does b equals to c. Such that if we take the sum of a, b, and c, we're going to get 0. You can verify that. Now, using this, we can rewrite the left hand side. So our left hand side is going to become cosine squared. So let's start with alpha minus beta. Cosine squared alpha minus beta gives us cosine squared a. Added to cosine squared, we'll next take beta minus gamma and replace it with b. And then we have cosine squared gamma minus alpha, which we could replace with c. So our left hand side becomes cosine squared a plus cosine squared b plus cosine squared c. Fine. Now what we'll do, we'll for next transform cosine squared b to its equivalent sine squared. So we get cosine squared a added to 1 minus sine squared b plus cosine squared c. So using the fact that cosine squared b added to sine squared b, that's equals to 1. Fine. Next, what we'll do, we're going to rearrange the terms. So we'll going to combine cosine squared a and sine squared b. Then we have cosine squared c added to 1. Fine. Now cosine squared a times minus cosine squared b, that is a standard formula. We have cosine of a plus b multiplied to cosine of a minus b added to cosine squared c plus 1. So here we have used the fact that cosine squared a minus sine squared b, this is the square difference of squares of cosine and sine, that can be factorized to get cosine of a plus b times cosine of a minus b. Okay, fine. Next, what we'll do, we are going to change this a plus b. Okay, now cosine of a plus b can be changed by taking the help of a plus b plus c equals to 0. So we have already established that a plus b plus c equals to 0. So a plus b is going to be equals to negative c. If we take cosine on both sides, so we get cosine of a plus b, that's going to be equals to cosine of negative c. However, cosine is an even function, so cosine of negative c is the same as cosine of c. In other words, we have shown here that if a plus b plus c equals to 0, then cosine of a plus b is going to be the same as cosine of c. So we're going to replace this cosine of a plus b with cosine of c. So with cosine of c multiplied to cosine of a minus b added to cosine squared c plus 1. Now from the first term and the second term, we're going to take cosine of c as the common factor, such that we have cosine c multiplied to cosine of a minus b added to cosine of c. Now we have cosine of c remaining, but as we can see, cosine of c, this is the same as cosine of a plus b. So let's replace cosine of c with cosine of a plus b added to 1. So this is going to be equals to cosine of c. Now we can combine these two cosine function. We have a standard formula for that. We'll get 2 times cosine of 2a over 2 multiplied to cosine of 2b over 2 added to 1. So here we have used the fact that cosine of c plus cosine of d, that's given by 2 times cosine of c plus d over 2 multiplied to cosine of c minus d over 2. So now we get 2 times cosine of angle A times cosine of angle B times cosine of angle C added to 1. Now let's finally substitute the values of A, B and C with the respective expression. So cosine of A, we consider it to be alpha minus beta multiplied to cosine of B. B we supposed it to be beta minus gamma multiplied to cosine of c, so c was gamma minus alpha added to 1, and this is exactly the expression on the right hand side. So we can verify that we did it. 2 times cosine beta minus alpha, cosine gamma minus alpha times cosine alpha minus beta added to 1. So here we have successfully verified that thus the left hand side equals to the right hand side. Hence